Hello, welcome to this lesson where we're going to look at the language involved in probability. We're going to be using a lot of this and some of it you've already seen, so make sure that by the end of this video you understand what each of these things means. First we have a probability experiment, and this is the overarching idea of what we're doing each time we're calculating the probability of something. It's just an experiment or a situation which is involving chance. Something like throwing a dice or drawing a card out of a deck of cards. Each of these is a probability experiment. It's the thing that you're doing. Next is the outcome. Outcome is just one result. So for example, if we're rolling a dice has 6 possible outcomes. One outcome would be rolling a 2. Another outcome would be rolling a 6. Outcomes are just one of the results. Sample space, on the other hand, is all possible results. Now, in the case of a dice, so we'll go for a dice here, and we'll go down. For our outcome for a dice could just be a 2. For our sample space, we're going to use these squiggly brackets, the curly brackets, and we're going to write all possible outcomes. So 1, 2, 3. You would continue on one line, but I've run out of space, so we'll go to the next one, 4, 5, 6, and then we close our brackets. So that's our sample space, and we always want to write it using these brackets here. So that's something important to remember. Now, P of event, this P here just means probability. So we're finding the chance, or how likely is this thing to happen. And P of event, we're going to get a number which is greater than 0 or greater than equal to 0 and less than or equal to 1. So it's going to be a number between inclusive of 0 and 1. And the probability event, the way that we find out what the probability is, and you would have done this last year, is to have the probability, the number of results that are within this event. So results the number of results that we want over the total results in the sample space. So if we go back to our dice situation, if we were wanting to work out what's the probability of rolling a 2, we would write something like P of rolling a 2. Now in this case, the results that we want is a 2, and there's just one of them. So this, I should say number. So that there is a number of results that we want. So the only result that we want is a 2 being rolled. So we're going to write 1 because there's only one that we want. And then we're going to divide that by the total number of results in the sample space. Again, that's 6 of them, 1 through 6. And that's this number here. So how many are here? That's the number that goes on the bottom. So it's 1 on 6. If we wanted the probability of rolling a 2 or a 3, we could then have 2 possible options and it become 2 over 6. But that's just how the P of event works. Now, complementary events is perhaps a new term. These are events that if we add them together, we got the whole sample space. So it's something like rolling a 6 would then be the complementary event of not rolling a 6. So this, when we add them together, give a probability of 1. Or another way of saying it, which might be more helpful, is when we add them together we get the whole sample space. So we give a probability 1 or whole sample space. Now there can't be any overlap in complementary events. So not rolling a 6 and not rolling a 1 aren't complementary events that we could add up. So it needs to be not rolling a 1 and rolling a 1. things that are the opposite. If we were to have an event C, the complementary event we would then write with a little dash next to it, which just means the complement of it. But we will go over this again in class. Next we have these words, and you've heard these words before: at least, at most, not, and. So at least means that we're going to have, at the bare minimum, that many things happen, or this thing's going to happen at the very least. So it could be greater, but it has to be at least that number or bigger. If it's smaller, it doesn't count. At most is the other thing. We can't go over that number. Anything smaller is okay, but once we get to that number, we can't go past it. Not would be the probability of not rolling a 6 is going to be the opposite of the probability of rolling a 6. So not is going to be the opposite, or the complement. And is going to increase our sample space. So if we have the probability of rolling a 1 and the probability of flipping a coin, we're going to then have a bigger sample space. Again, we'll have more practice with those in class. Finally, we're coming to the word or, and this is a very important thing to get your head around, because this is a lot of what we're going to look at in this topic. So looking at Venn diagrams and two-way tables, an exclusive and inclusive or comes up throughout those. When we say or, it can mean two different things. If I said I want this or that, it could mean that I want either this one or I want either that one, and I don't want them both. Or it could mean I want this one or that one, or I want both of them. So exclusive or is the one that just has one or the other. It's going to be the not both. So that would be something like, what's the probability of rolling a 6 or flipping a coin and landing on heads, but not getting both? In contrast, we have the inclusive, which is the this or both. Yeah, so or both. Or we could write and or. So we've got two different ideas happening there, and we will look at these again a bit more in class. But it's when exclusive or is when I want the probability of this happening or this happening, but not both of them happening at the same time. Inclusive or is when I want the probability of this happening or the probability of this happening, or them both happening at the same time as well. I hope that's made sense to you. If you have any questions, please do send me an email or come and talk to me. Thank you.